When we look at biomass and plastics, we mostly see waste. But chemically, both are carbon-rich materials. So let's start with a simple question. What do we really mean when we mention biomass and plastics? In this course, when we say biomass, we mean the organic material of recent biological origin that can be used as a resource. Here, you can find the definition. Generally, biomass is divided into 6 major types. First, forestry biomass such as chips, logs, and demolition wood. Second, agricultural residues such as straw and press cakes. Industrial and municipal organic waste. Fourth, energy crops, such as miscanthus or eucalyptus, which are specifically grown to produce energy or bio-based products. Fifth, aquatic biomass, such as microalgae and seaweeds. And finally, biomass derivatives from the food and bio-based industry. Let's look at what biomass is made of. Biomass is built mainly from 3 biopolymers: cellulose, hemicellulose, and lignin, plus water. Cellulose is a long linear chain of glucose. It has a crystalline structure and makes up most of the biomass. It forms the fibers that give strength. Hemicellulose, often seen in wood and crops, has a more branched and irregular structure. It is in the cell wall and helps to give flexibility. Lignin is an aromatic 3D-dimensional network. It acts like a glue between fibers and gives the material a stiffness and rigidity. Finally, water. Most of the water in biomass is stored in the hemicellulose and lignin parts. These softer, less ordered parts take up and keep more water than the crystalline cellulose. Key properties we care about in biomass are moisture. Moisture content can be 10% in dry wood, but 80 to 90% in sludge or in manure. Bulk density and grindability. Loose straw versus dense pellets behave very differently in reactors. Ash and minerals. Potassium, chlorine, and phosphorus drive slagging, fouling, and corrosion in thermochemical systems. Now, let's talk about plastics. In this course, we define plastics as very long chains of small, repeating building blocks called monomers. When many monomers join together, they form one large molecule called polymer. Plastics are classified depending on a variety of factors, including origin, structure, molecular forces, polymerization mechanism, temperature-dependent behavior, and preservation techniques. When we look at plastics at the molecular level, especially before and after heating, we can group them in 2 main types of polymers. Thermoplastics soften when heated and can be remelted and remolded. These dominate packaging. And thermosets, cross-linked, do not melt, and they char when heated. Think about epoxy resin, polyurethane foams, and some composites. In 1988, the Society of Plastics introduced the Resin Identification Code, RIC, dividing plastics into 7 categories: PET, commonly used for bottles and food containers; HDPE, known for its strength and using milk jugs and detergent bottles; PVC, used in pipes and window frames due to its durability; LDPE, flexible and used in plastic bags and films; polypropylene, strong and heat-resistant, used mainly in food containers and car parts; polystyrene, versatile and used in disposable cups and packaging; and finally, other plastics, such as polycarbonates and other mixed plastics. In the next video, we'll talk about the technologies to convert biomass and plastics into useful products.